Hi, I'm Lindsay with RCR Wireless News. I'm here with Kevin Duffy with Fastback Networks. Thank you for joining me.
Thank you for having me.
Great. So tell me what you're showcasing today at CCA.
Well, today this is sort of our debut. This is kind of the first time we came out in a public setting. It's our first booth, brand new booth. We're a startup company out of San Jose, California, and we're showcasing what we call our intelligent backhaul radio. This is a radio that is intended to assist small cell deployment, macro cell upgrades, and even for connecting to buildings. So basically, like the sign implies, fiber is everyone's first choice. Everyone knows that, and you get all the bandwidth you need, you get the services you need, you get low latency, high performance. And in the case of many of the macro sites in the world today, 60, 70, maybe 80% of the time, they get fiber there, and they architect their network to the existence of fiber. But when fiber's not there, it doesn't reduce the service requirement. That stays the same. So we're the first radio company in the world that actually thought about how do you deliver the equivalent of fiber, the speed, the performance, the low latency, the Ethernet services, and the features that would all be required to guarantee a service level agreement in a complete non-line of sight, near line of sight, or even in a line of sight environment. And that's what we call our intelligent backhaul radio.
Great. And kind of, what would you say the defining thing that sets you apart from competition or anybody out there?
Well, it's a combination of things. There's a lot of technological innovation in the product. First of all, the raw speed and performance, the 500 megabits per second in complete non-line of sight is a breakthrough. That, combined with the very, very low latency, 500 microseconds, S1, X2, eNode B interfaces strictly define latency that's between one peer node to another. And to be able to maintain that in a non-line of sight environment, it's not uncommon in a line of sight environment, but in a completely unpredictable non-line of sight environment, 500 microseconds of latency, regardless of packet size, or with say very little variation of packet size, is very novel. The other thing we did is we eliminated the need for having on the site a router, a switch, a timing device for synchronization, 1588 and SyncE, and yet another device to do OANM and things like that. We've taken those 4 or 5 elements which go in a rack and included that functionality in our box. So we have one small form factor, which is the equivalent of 3 or 4 managed elements now in one managed element. So think about small cell. If you have to have all these things on a pole, you can't have 4 or 5 things to perform one function. So we've consolidated performance, latency, installation, alignment, and reduced number of managed elements into a single package.
Very nice. So speaking of, what do you see the trends, kind of what's on the horizon? You're just starting out, are you guys keeping in step? It's all about...
Just to share just sort of a philosophy and how we see it is, this is about bandwidth per square area. If you think about it in a simple term, is that over time, every operator, whether you're a competitive carrier or tier 1, you need to create more bandwidth per square area available to each individual user over time. And the way they're going to do that is by putting layers of technology, macro technology, small cell technology, and Wi-Fi technology. And that's what we're all about, is every one of those devices needs to be connected to the internet, and every one of those devices are going to have a high performance service requirement. Yeah. And so that inevitability of that bandwidth per square area, that's what we see is the trend. And if you think about it, what you're really doing is you can't change the number of people, you can't ask them to ask for less. So what you're really saying is let's just change the ratio of the number of access points per user. You don't think of a base station as an access point, you think of a Wi-Fi as an access point. But the future devices, the trend is they look more like Wi-Fi APs than they do like base stations. And so change the ratio, fewer people per access point, therefore a better quality of service. When you do that and you're combining LTE and Wi-Fi, maybe even in the same box, then you get hundreds of megs of capacity, hundreds of megs of backhaul requirement, and different types of service requirements. Wi-Fi is fee versus free. Maybe people give Wi-Fi away and try to upsell people to the more high-performing LTE. So to me, that's sort of the inevitability that's behind the trends, is if you just stay focused on bandwidth per square area, realized by layers of different radio technology, create seamlessness, and then what we can do is give people the confidence to put what we call freedom of location, put those devices where you want to put them, not where backhaul is, and we'll get you to the nearest point of fiber relief, and we'll make sure that when we make that connection, it'll be at the same level of performance as fiber.